Testing, 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 testing. Fucking love my new mic. So sick. What's up, Roy? How are you? Feels good to be streaming, not gonna lie. I missed it a bit last week. I missed one day and then I like finished early another day because I was like super busy last week. Working away, nice. Do you have like a lunch break and stuff, or do you just kind of like cram everything into your day? Like, how does it work? I don't know, like working from home, kind of weird to me still. I don't know what's going on. I might upgrade my account to affiliate. I got the necessary bits and bobs, got the email. Could be kind of fun. I'm not seeing too much of a benefit from the YouTube double streaming. Take a lunch break, do 40 hours a week, sometimes there's your workers, yeah. That's what I see by working from home, so flexible. Bum bum bum. Okay. Right. What's the plan this week then? I haven't done much looking since last week, so yeah, I want to finish off these two papers. Actually, I don't know if they're papers or articles, but we'll look at them anyway. And it's about Nili Fossae again. See if it'll bring us anywhere, and then if not, we'll try and figure it out then, I guess. We did a good bit of work. Let's look at the notes we have done so far, okay? So we actually have a good bit done. This untitled page is like this, like the first week of work where it was like working on Python and it was working on Excel to try and get some basic equations running. Then we have a good bit of the balloon literature done. This is all like past, balloon literature is the wrong word actually. It was a lot of past balloon experiments, but there was also some like planes in there, winged experiments, not just balloons. That was a good chunk of the work. And then this is just like trying to summarize the last few weeks then. We got 2 more weeks of the balloon literature, good bit. More of and then we went into just lucky materials. I tried to make an Excel sheet and like work through what I thought were the most important materials, but I didn't find that too useful. I don't see myself deviating too far from what's been tried and tested before with materials. See, not 100% sure on that yet. And then yeah, this week then, or well last week, we were focusing on Nili Fossae, which is the area we're looking at in Mars. So yeah, let's plow ahead. I want to open up these links first. I need to change my default browser to Chrome. I still have it as fucking Microsoft Edge. Okay. So this is a paper and this is a paper. Okay, dope. Again, more to the methane stuff, which was last week. I know is a weird one. Like I was looking to get more methane information about Nili Fossae, but then it just turned into like a big methane review. But it's good to get a little bit of this done now, I guess. Not to worry. Alright, let's get a new page and OneNote going. Lines. I don't know what to call this yet. I'm just gonna leave it blank for now. Okay. So we got our goals here, and then I need to get better at figuring out how to do this properly. I'm just trying to make sure I can get all the letters on the screen for you guys. Okay, I think that looks good. Oh, I fucked it again. I think I need to write a sentence before I get rid of it, maybe? Yeah, there we go. Alright, what's up? What are the goals? So, finish 2 Nili Fossae papers. Any interesting links that come through these I can explore. There we go. Nice. I wanna, like, there's way too much of the left margin in play. I wanna get rid of that. Yeah, there we go. Nice. Perfecto. Oh, it went back over there, right? Yeah, it did. Okay, so... Geez, who would have thought this would be this hard? Maybe it zoomed in too much. There we go. That looks better, I think. Okay. I don't know what else to write down for today. I think I'll just come back to this and fill in as I go, because I think today is a bit of a freestyle day. Just gonna see what happens. Okay. Paper 1. I'll say paper. And this is methane seepage on Mars. Where to look and why. This by Dorothy Z. Euler. Okay, methane on Mars is a topic of special interest because of its potential association with microbial life. Variable detection of methane by the Curiosity rover, orbiters and telescopes, coupled with methane's short lifetime in the Martian atmosphere, may imply an active gas source in the planet's subsurface. Yeah, this is saying that because we're seeing different levels of it happening all the time, and it's still happening, because methane kind of dies off quite quickly, there has to be something there that's making it still be produced. And this can be, I think, one of two things. It can be microbial life, or it can be, I think, something to do with like volcanic rock or something. I know the second one is definitely more like geology based, and the other one is biology based. I don't think there's anything else. Maybe something to do with like the carbonate rocks and maybe some water content, I actually don't know, but I'm pretty sure it's just two things. Pretty sure it's just two. Okay, let's keep going. Here we reviewed a variety of subsurface processes that could result. Let me get my mic a bit closer actually. That could result in methane seepage on Mars. Okay, yeah, so this is saying they're gonna look through all the processes that like is why methane's created in the first place. Such methane could originate from abiotic chemical reactions. Okay, so one's chemical reaction, one is thermogenic alteration of abiotic. So it's just like how organic matter, is that related to microbial life? Okay, no, it's different. So it's saying the heat or something that comes off of like this sort of matter, and also, so there's three things. Okay. The last one being the microbial life, the metabolism of it. Let's note that down. We're getting a bit into methane this week, I guess. Let's just embrace it, let's just go with it. Let's not get too scared, boys. Okay, so cover the variety of overground. I don't think there's any of those processes at all with methane, so let's just roll with this. That could result in methane seepage on Mars. And they talk about three of them. Abiotic chemical reactions, thermogenic alteration of abiotic or biotic organic matter. Ancient or extant. Extant means extinct, right? Microbial metabolism. Okay, so there are the three things that can lead to more methane. Okay. These can... Where are we? These processes can occur over a wide range of temperatures in both sedimentary and igneous rocks, and together they enhance the possibility that significant amounts of methane could have formed early Mars. Okay. Back over here. All evidence points to... towards... early formation of methane on Mars. Methane seepage to the surface would occur preferentially along faults and fractures, which Nili Fossae is, so that's a good thing to point out. And this is through both macro seeps, and the other one is diffuse micro seepage exhalations. Jesus Christ. Diffuse micro seepage is that a word? Yeah, it is. Exhalation. This is a fucking dope ass paper, to be honest. Like if it's doing what it says it's doing, it's gonna locate all the different places that there's a good chance of methane coming out. This is like the criteria I need to look at to choose why we're going for Nili Fossae in the first place. So this is good. This is good stuff. Okay. Hmm. Okay. So where are we here? It's going through these places. Okay, I just noted down that they go through places. I'm not gonna actually go through them yet. I mean, I might as well read them. Mud volcano in blah blah. Ancient springs and rims of large impact craters. Okay. Could have been locations of past big seeps, and they could still be emitting methane today. That's only if they have a source that's producing it there at the moment. Because of its low, methane kind of goes kind of quickly, and especially when you have a low atmosphere on Mars, low meaning low density, it just doesn't keep things down that often, so things kind of leak out quite quickly. Okay, so that's the macro seepage. Micro seepage could occur through faults. Okay, so it suggests that Nili Fossae has mainly micro seepages. Okay. So it's saying more places. Yeah, we saw this a lot last week, the serpentinized rocks. So I'm going to put that down again because that's the second time I've seen this now. Serpentinized rocks. Mentioned again. This keeps on coming up over and over, so I'm going to have to look into this a good bit more, I think. Martian microseepage would be extremely difficult to detect remotely, yet could constitute a significant gas source. Okay, so even though it has micro in the word, it's saying microseepage could be a big deal. So microseepage is difficult to detect remotely. That's also a good reason as to why balloons could work as a detection kind of mechanism. If it's hard to detect remotely, you get the in situ measurement with the balloons. Could be pretty dope. So I'll definitely be highlighting that in a few minutes. So let's keep it there for now. Oh, it's difficult to detect remotely, and also could be a significant source of methane plumes. Okay. We emphasize that the most definitive detection of methane seepage from different release candidates would be best provided by measurement performed in the ground or at the ground atmosphere interface by landers or rovers, and that the technology for such detection is currently available. Okay. Paper highly recommends in situ detection and what am I spelling wrong? What am I spelling wrong? The fuck? Detection. Am I not spelling this exactly as it is here? Am I tripping? Let's go with it. Copy paste. Okay, come on, come on. Yeah, this is terrible, terrible stuff. Okay, let's move on. Highly recommend in situ. Oh, I know, I wrote down detection twice. I'm such a bad person. In situ detection, and the technology is already there. Okay, nice. So let's get to the meat of it now. This is only the abstract. Intro. Okay, here we go. Methane on Mars, topic of primary interest because of potential life on Mars. Methane can be generated by microbial communities. Methane, like other gases that can be produced in deep rocks, can also be proxy for dynamic geologic and subsurface fluid circulation processes. Okay. Spatially and temporally varying CH4, 0.2 to 60 part per billion, I think it is, has been detected in the Martian atmosphere by Curiosity rover in the Gale crater. Okay. Talks about varying methane content detected by Curiosity rover, and we kind of knew that already. I think we saw that last week. There's a big discrepancy between what the orbiters measure in methane on Mars and then what the rover detects on Mars. What's up, Rockstar? How are you, man? Good to see you. Thanks for hanging out, bro. How's the streaming been going? How's the bouncy ball going, man? I fucking love that bouncy ball, man. It's so sick. Where are we? Good, good, good. Is that your emote? Unbelievable. That's pretty cool. Are you streaming today? I haven't seen this before. Methane generated above the surface due to electrical discharge. Interesting. Oh, you just kind of jump on whatever. Fair enough. I kind of like the kind of schedule. I kind of go on when I have to go on, you know. Yeah, Rockstar is a really cool channel. I really, really like it. You're really good at like chatting away with chat as well, I think, Rockstar, as you're working. It's really good shit. I actually really enjoy watching it. What am I noting down here? I think it was the electrical discharge I looked at. This one here. Okay, so it talks about methane generation, is it? That's the wrong word. Generation is wrong. It did say generation there though, so maybe I'm being too tough on myself. Talks about methane generation above the surface. electrical discharge near ice ground. And that's, they have a reference there as well, so let's write it down. Robledo, and Martinez, 2012. Okay. Or UV irradiation. Yeah, man, sounds fucking good. What's going on here? But as is the case on Earth, larger amounts could be produced in the Martian subsurface. Yeah, okay. So it's saying that it's only a little bit. Only a little bit. Main methane on Mars comes from subsurface activity. Yeah, so I've seen this a few times too about the methane could be coming from a present day source or a past source. Depends. Sometimes the methane can get stuck up in rocks and then it doesn't actually come out for years and years and years. So yeah, formed in the past and subsequently stored in clatrates, zeolites, or reservoir quality rocks trapped below sealing lithologies. Essentially, it's just like gets formed with the rock, like the chemicals in the rocks, and it just stays there, it just chills. Methane actually only disappears when it goes above the surface, and it kind of like a helium balloon, you know, it just kind of keeps on going up. Kind of what goes on here. And as I was saying earlier on, because the atmosphere of Mars is like super not dense, things just kind of seep out. It's sort of like having a parachute with a lot of holes in it. It just kind of goes out through the holes. That's kind of what's happening here with methane. So if it gets stuck in the rocks, it can stick around for a good amount of time. Subsurface sources could be really, yeah, I read that. The possibility of active subsurface sources of Martian CH4 implies the existence of a gas migration process known on Earth as gas seepage. Okay. Accordingly, in this paper, we concentrate on the subsurface mechanisms that could account for Martian CH4, including its generation, storage, and seepage to the surface, as well as the likely physical manifestations of that seepage on the surface of the planet. Huh. So they're not really caring about the overground stuff, I guess. Because as they said, the main source comes from the subsurface bits and bobs, so it's fair enough. Okay. Did I spell micro seepage wrong? No, it is just a fucking stupid word. Okay. We address these processes in detail. Okay, yeah, I like the sound of this. Again, I probably won't go too in detail on how it all works yet. So I'm just gonna write down paper goes into detail on what's it go into detail about? Sub methane processes. Based on decades of studies and research. Such conclusions neglect the array of geologic processes that could produce CH4 in Mars. Claterates occasionally have been misconceived as potential origins for Martian methane. Yeah, okay, so yeah, what I was saying earlier on, the methane gets produced by something, it gets stored in this rock for like ages, and then it comes out. Then naturally, if it stays there for so long and you see it come out, it's easy to consider that that could be the source of it, but it's actually just a storage mechanism, as it says here. Here we address the scope of potential CH4 generation processes for Mars, including some processes not generally recognized, and we clarify details of serpentization and Fischer-Tropsch type reactions. Okay. So they conclude by combining all the above to identify sites or regions on Mars that may be prime candidates for methane release and may be priority targets for orbital scans, landed ground-based analysis. Okay, I might just skip right to that section and see what the story is there. And I'll note that this paper needs to be looked at after. What's my schedule again? I basically like looking at all in one go, so I don't like kind of. I guess I've done a little bit of it now where I've done a bit of work on the balloon, bit of work on Nili Fossae. I've done a bit of work on what else? The materials. But I kind of dig into one aspect, so I don't want to get too crazy with the methane stuff here, because this could be a very key important paper when I do go back looking at methane stuff. So I might just look at the geography and then come back to this later on. Some cool pictures though. This is this is the different processes that can happen, and it's saying how to, like, the rocks around it and stuff can store the methane. It's pretty sick. Let's keep scrolling. So this is the seepages. Again, I'm just gonna roll right past this. The micro seepage is what's important in Nili Fossae. Interestingly, it's a very small paragraph though. Don't like seeing this. There's only one process that could lead to biological processes of methane. Then there's a lot of geologic ones, especially near Nili Fossae where there is magma and volcanoes. It just means it's a little bit less likely it's biological. This is a pretty dense paper. So what's going on about the microbial stuff here? What's this? Some reaction. Oh. Keep on going. Okay, potential landing sites. So we should get some places here that, based on this paper, they're basically saying that these could be places where there's a good chance that there's life on Mars. So let's see what they say. Where are my notes? Okay, so revisit this paper when going through methane study. Very in-depth. Paper compares and contrasts various locations on Mars as potential areas to investigate with regards methane content. Yeah, fucking badly worded sentence, but you get the gist. You catch my wave. Okay, so I'm just looking for Nili Fossae. I could just Control F. Ooh. 28 times, okay. This element paper is like the goat of Nili Fossae. I need to go through it much more carefully than I did last time. Okay, serpentinization. This is where we're getting into the nitty-gritty stuff of Nili Fossae, so let's read this. So the process for producing methane earlier on was H2 plus CO2, or I think it was 2H2 plus CO2 gives you CH4 plus O2. See? Oh, CH4 plus 2H2, okay. So CO2 plus 4H2 gives you methane and water, okay? So if we go down again to here, yeah, so you have the CO2 from the atmosphere of Mars. Like, Mars' atmosphere is basically fully CO2. So where do you get the H2 from? And then this is what this process is. I can never pronounce it. Serpentinization. Serpentinization. It's like a snake, right? That's happening all the fucking time at Nili Fossae, and it's just pumping out this H2. It is pumping it out, and it's just reacting with the CO2 in the atmosphere and making your methane. So that's probably what's going on in Nili Fossae. But for Mars, it's particularly important because A, it has been actually detected by CRISM, and it can occur in ultramafic rocks that host the necessary catalyst for the FTT Sabatier reaction. Now, my question is, does this mean that the methane at Nili Fossae is just like definitely because of this and not because of biological life? That's the big question. So let's write that down. Serpentinization produces H2, which reacts with CO2 to make CH4. C balanced written above. Okay. Oh yeah, my question is, could this mean that the methane at Nili Fossae has no ties to biological life? Question mark. It's a tough one. I don't know. It depends how much, right? So let's get my notes up for a second. One thing I'm thinking of at the moment is characterize the methane you would expect from serpentinization process. Measure how much methane is coming. from that area. If there is a surplus in the measurement, where and why is the X, or no, where is the extra CH4 coming from then? That might be like a sort of fundamental thinking that like has to take place in trying to detect if there is biological methane going on. I think that makes sense to me. Okay, let's move on. Okay, so it knows the serpentization is happening because of Chrism. Let me know that. So Elman's paper is the one to look at for serpentization process. In addition, recent work on Martian crustal petrology. I have no idea what that means. Let's look it up. Petrology, here we go. It's the branch of geology that studies rocks. Isn't that what geology is? Here we go, boys. Let's check it out. Is an earth science concerned with the solid earth? Okay, so geology is all about the earth. I didn't know that before. The rocks is composed of is just one part of it. And petrology is specifically the rocks and how they form. Okay, that's important. So petrology is the rocks and the formation of the rocks. Okay, so it's just saying that the serpentization process might be actually really important in production of H2. More so than radiolysis. Not too sure what that is. Contemporary studies show that serpentinization would account for more H2 than we previously realized. Olivine and pyroxene required for serpentization are common minerals on Mars, as shown by a variety of orbital and rover-based studies, as well as analysis of Martian meteorites. And a fuckload of study done there on that. I've talked about the serpentization process before, so I actually don't think I need to note it down. We were talking about it a bit last week, to be fair. So yeah, it's at Nili Fossae, cool. So like what's going on here is I'll just type it out just so I know what's going on. We know that serpentization is a process that produces H2, okay? We know that to make CH4, which is methane, we need to react H2 with CO2, okay? They're just two things we know, okay? Because atmosphere on Mars is full of CO2, if we have a load of SERP going on, I'm just gonna say SERP. If you're SERPing away, if we have a load of SERP going on, then we should get a load of CH4. Simple facts. That's what's going on here, I'm pretty sure. This is like just everything that's going on at the moment in this paper can be summarized as just one sentence. One sentence, maybe 3 sentences, but you know what I mean. I'm just trying to get a picture in my head of like when I'm writing this stuff down, like in like a presentation or in like a interim report or even my thesis. Like I need to tell a story, you know. So like where do I start? So I'm trying to think now already. When I go to write this stuff down and like to hand it in, where am I gonna start? What's the story I'm trying to tell gonna be? But like. I'm starting to think discussion of serpentinization could actually be an important one to talk about. First, we're looking for CH4. Where do we look? Okay, we know that we need CO2 and H2 to make CH4. We know we have CO2. Where's the H2? Oh, we know the H2 is made through this process. Oh yeah, cool. Where is the best place this process is happening? Probably Nili Fossae. And it just leads to a conclusion that we should check it out, I guess. Now, this is the exact question I want to get answered. I love this just here. Like, what are its implications for life on the early Earth and Mars? Because I would have imagined that this implies nothing to do with life on Mars. I must be missing something. Because this process that I've written down here, this doesn't have anything to do with life on Mars. Or maybe I should check out this. They discuss serpentinization here, right? Because that could be why. I'll just Google it. Serpentinization. What happens? So it's a geological process. Hydration and metamorphic transformation of a rock. So it's just a rock that changes. Yeah, it has nothing to do with has nothing to do with life, right? I could be tripping. Let's just keep reading. Hang on a sec. Okay, I need to take a picture of myself. Wait, flip it. What is she saying? Because I'm pretty sure when I did it in selfie mode that right? You're back 1 second. I always forget about my mic being muted. Fuck. We're back. We are back. One sec again. Alright, what's up? I think I'm good to go. Okay, where did we get here? I think I scrolled up a bit and then I was kind of defining what serpentinization was. So let's go back down to the potential sites. Yeah, so right here. They're going too far? No. Let's skip this to last time, I think. Or did I? Oh, so it has a whole section of Nili Fossae here. Pretty cool. Okay, it's gonna go back up again. Yeah, so around here was where we were initially reading, and it was talking about what serpentinization actually is. So just saying that they investigated these areas that like seem to show serpentization. Pyroxene and olivine are like components that you need for serpentization. Saying it normally happens in crater walls, rims, and ejecta. Not too sure what ejecta means. Oh, okay, so this is interesting. It's saying that, like, yeah, all the bits necessary for serpentization to occur are in all these places, but actual serpentization isn't happening that often. So saying Nili Fossae is one of the only places where it actually does happen. That's interesting to know. Let me write that down. Okay. Okay, we're below. Oh, what are these pictures? So yeah, it's saying faults and fractures are where micro seepage can occur more often. So these are some faults and features on Mars, I guess. Nice. Scroll down. Okay, yeah, so I need to actually say what those ingredients are, I guess. Go back to the notes. Ingredients equal olivine, pyroxine, is it? Pyroxene, and liquid water. Yeah. Okay. Blah blah blah. Olivine and pyroxene are clearly abundant in the highlands. Relatively recent data suggests that lowlands too contain significant buried basalt that is rich in these key minerals. Okay, not much going on. Deep basins of lowlands would be places where a lot of water would be. Yeah, you'd imagine that. And the falls, yeah. I think that's why Nili Fossae is good as well, because it's quite a big valley. So it's easy for water to get trapped down there, I guess. Let's get back to this. Yeah, that's a fair point. Okay. Potential sites of methane accumulation on Mars. Now this is the nuts. This is what I really want to get into. Because through this section, I'm going to be able to determine why Nili Fossae is like the place I need to check out. So let's have a look. I'm gonna do a music change as well. I'll put on like this 2-hour video, but I think it's like going back over itself again. Okay, back to the paper. So I assume the traps and seals are specifically about the... yeah, like when it gets stuck in a rock and stuff. So I suppose it's going to go traps and seals, and then the next one is going to be reservoirs, and then seepage. Yeah, okay. Let's see. Plates, tectonics have been minimal. And why is this important? Bum bum bum. This is really interesting, actually. Where did I say? See, Houghton Crater. Like, I really like it when, like, this paper has been really sick so far. Like, it talks about a process, and then it talks about, like, an example of that process on Earth. So it's kind of interesting to read about. It's saying here that the Houghton crater, it was made from some impact, and that it's like super complex, with like a lot of hydrocarbon getting stuck, and that's the exact same thing that's happening on Mars right now. So it's cool to see. For example, on Earth of compact and not tectonics. Impacts on Mars are abundant in both the southern and northern highlands and lowlands. Even though many of the oldest craters in the lowlands have been buried by subsequent sedimentation, only detected by ghost or stealth craters. Okay, cool. So this is like a bit of a diagram explaining this, I guess. A simple crater versus a complex crater. I don't really know what the difference is, so let's see. Complex crater adapted from blah blah blah. Dash arrow indicates potential CH4 release associated. Okay. So in a simple crater, you're getting CH4 coming up. It's hitting this kind of land here, and it kind of seeps up the side. And you're only getting it coming up here and here. But here, it just seems like it's kind of happening a bit more sporadically. You have some happening in the middle, mainly coming to the sides though. Huh. And yeah, it's saying that, yeah, if it's trapped, fair enough, but you need to be sealed. It's a long paper, but getting a lot of information out of here, so I don't mind taking too much time. What's going on here? This place is a fucking banger, not gonna lie. Okay. So when it says reservoirs, yeah, it's not about these rocks. I wouldn't imagine they'd be porous rocks. Maybe porous rocks. Maybe it can like have a layer of permafrost because of the fact that water can get through it. But I would imagine that porous rocks would have had holes that the methane could seep out of. Whereas something like a clatrate, it's like so thick and dense that like it gets stuck in there. So I'm not too sure why a porous rock would be a reservoir. Like you would think a porous impermeable rock would have space for methane to flow out through. So it's a little bit confusing. Okay, so the idea is that it has storage space for gas or liquids. And that maybe if it's the right type of rock, maybe the chemicals inside the rock, maybe it keeps the methane sticking to it instead of flowing out through a hole. Bum 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 bum. This has been mentioned already, basically saying that because there's no plate tectonics, you'd imagine that there'd be less of a chance that like irregular land can form. But it's saying that Mars actually had quite a big history of like meteorite impacts and things like that. So that's what leads to the damage of the Martian surface instead, and it creates these like kind of networks, what they call pathways, that the methane can fly up through. Okay, here's the nuts. We don't care too much about macro seepage. It's the micro seepage is what is cool for us, I think. I forgot to tweet saying I'm alive as well. Not that it would matter. But sitting on that big donut followers to 0. But hey, gotta get the good habits started. Oh. Okay. Okay, I want to get to the micro seepage area, and then I'm going to take a quick tea break. Okay, potential zones of micro seepage. Number 1 of Nili Fossae. I like the sound of that. I'll come back up in a second now. Abiotic. Okay, so yeah, saying that, like, what I've been kind of hinting at a lot recently is I think that Nili Fossae, while it has a lot of methane, it might not be biological methane because of its, like, I don't know, I thought it was because of volcanoes, but there might be more reasons. But regardless, I think it's still worth looking into because there's no point picking a new place now. It's still well worth looking into. Okay, boys, gonna go make us a cup of tea. Be back in a tick. Alright, BRB everyone. Yo, yo. Alright, let's check out some of this. How good is this playlist? Oh my god. Banger. Okay, check out the Elon Musk one.
Buddy, and welcome back to the Space News Pod. This is a show about space, science, and tech. I'm your host, Will Walden. And on this episode, we're going to be talking about Starship. First, we're going to get into SN10. So SN10 had a little hiccup. There's an engine issue going on, and we're going to talk about that a little bit. We're going to tell you what the timeline is going forward with SN10, when hop, etc. And also something really cool from Elon Musk about the Starship platforms in the Gulf of Mexico. What? That's all I got to say is what? Now let's get into SN10. Okay, so we all know SN10 is poised to launch soon. And here's a tweet from Mary Boca Chica.
SN10 was rolled out like maybe 3 weeks ago, 4 weeks ago. And that was when SN9 SN9 was supposed to launch, and there was some like licensing issues, so they held back the launch for like a week. But SN10 and SN9 were on the launch pad at the same time. SN9 launched and it blew up, unfortunately, so SN10 is going to be the next one, and yeah, it should happen in the next like 2 or 3 weeks probably.
An aft flap has been deployed on SN10. This is a couple days ago, February 21st. Good chance of flying this week, says Elon Musk. Okay. So
this week. Jesus,
that chance has kind of drifted off a little bit.
Okay.
SN10 had a little hiccup, and here's why. They are going to be figuring out an engine issue. Here's the static fire from last week. SN10 static fire. This is from Brady Keniston. Sorry. SpaceX ignites Starship's SN10 Raptor engines for the first time. It is unknown if the test was successful. Mirror received a notice that testing may occur on February 24th as well. The Favoritist on Twitter at the Favoritist. So Elon says, this is important, one of the engines is suspect, so we're swapping it out.
Okay. That'll take a while.
And if you haven't checked out our Starship Sus t-shirt on our shop, go to spacenewspod.com. Very cool. I don't have a screenshot of it right now, but it's really cool. I'll show you at the end of the show. How much do you anticipate the engine swap will impact SN10's flight window? So the first engine swap for SN8 was slow. It was like 20 days. It was almost a month. SN9, about a day. Maybe 2 days, couple days. They already swapped this one out. They're already in the process of swapping this one out. So it's about 24 hours to swap this thing out right now.
That's short. So I would imagine a bit longer.
They got to test it. They got to do another static fire. All right. So going forward, they got to do another static fire. Today's Wednesday, by the way. Wednesday, let me check what day it is. The 24th. SpaceX already has February 25th for the TFRs. And they also have, so that's tomorrow, Thursday, Friday, and Saturday for TFRs. But they don't have one for today. So they're not launching today on Wednesday. But what did happen? The closure for the road has been canceled for the day. So they're going to be swapping out the engine, and there won't be a static fire today because the closure has been canceled for today. Thursday, the closure is scheduled. Friday, closure scheduled. Monday and Tuesday, there's another closure for both of those days. So it looks like SN10 will probably launch early next week because they have to go through more static fires to make sure this new engine works. They have to do another cryo load. They'll probably do a full wet dress. And then, so a wet dress is when they load everything up into the rocket and they're ready to launch it, but they don't hit the launch button, basically. So they're ready to go. Doesn't fly, though. So they could do all that between tomorrow, Thursday, and Friday. They could do static fires Thursday and Friday. And then they could do a wet dress on Monday or cryos and all that stuff. And then Tuesday, we'll probably get a launch on Tuesday of next week, the March 2nd
Today?
of next week. So,
No shot.
That's a thing that may happen. We may get a launch early next week, which is going to be great. And I can't wait for it. But there's something else that's really like, how crazy is Starship to begin with, right? It's a skyscraper. It's a skyscraper that'll be sending people to Mars.
Fucking
like
huge.
Hundreds of people, thousands of people, millions of people eventually to Mars. Some form of Starship will hopefully be sending those people to Mars. But right now it's in the early
There's
testing
Carl
phases.
Sagan in the back.
And this is wizardry. This is crazy. And this is something that I never thought I would hear. I want to show you guys this. This is absolutely insane. Look at this.
Okay.
I want to show you this. This is on Twitter. ERCX, ERC, X space. Any further details on the rigs? So SpaceX will be launching Starship from
Pretty sick.
a decommissioned oil rig in the Gulf of Mexico. They already have 2 of them. So they bought 2 of them, and they're $3.5 million each, I believe. So they got them for a really cheap price. They're going to reconfigure them and make something that looks similar to this. Okay. I hope we don't go bankrupt building them. So it's going to cost a lot of money. Elon's like,
Interesting.
they have enough money, right? So they have enough money to build them. Totally enough money. But Elon's just making a joke. Hope they have enough money.
I assume when he says building them, he means like refurbishing them and making them what he wants. I don't think he's gonna actually, like, initially when I read that, I thought he was buying them and he was going to like look at them, how they were built, and build more maybe, but I don't get that vibe at the moment actually.
To build them. And then there's a couple other questions down here. How long do you think the rigs will be operational? How long until the rigs will be operational? One of them may be in limited operation by end of the year.
Whoa.
So limited operation, meaning
That could be a launch or a test
ship
launch.
things to it? Can they put a Starship on it? Can they take some photos, do a video? Could they launch from it? Because they want to go to orbit by the end of this year. How will starships, this is the cool part. Okay. How will starships be transported to the floating platform? Will these launch platforms be stationed permanently in the Gulf? This is where it's amazing. Elon says they will fly there from our launch site, stationed around the world. What? Okay. Okay. Starships will launch to the platforms, land on the platforms, stack up, and launch from there to orbit into other planets? Is that what he's saying? So there's going to be launch sites around the world and platforms around the world, and they'll just fly there. What? Or maybe the launch sites will just be in America. I don't know. I mean, who knows? But they will fly there from our launch site stationed around the world. So take from that what you will. But can you imagine? Let me know in the comments, please. Let me know what you think. If this is this possible? I'm freaking out now because this is crazy. I thought they were going to float out there on boats. Like traditionally, NASA transports rockets in the water on giant vessels. SpaceX is just going to fly the rocket there. No big deal. Just going to fly the rocket there, refuel, fly it up into orbit, fly it to other planets, wherever they're going to go. How crazy is that? That's insane.
It's pretty
That's
mad.
Absolutely insane. And Let me know. Yeah, let me know if you think that's even possible. Let me know if you think that's going to be a thing in the near future. But right.
So they're gonna build their rockets, and they're going to have their oil rigs in place, and they're going to essentially drive their rockets from where to these rigs. They're not even gonna build them at the rigs. That's pretty wild to think about.
Right now, I'm going to go back to
never
SN10
been
real
happened.
quick.
Never happened before.
SN10 not launching until probably early next week. There are going to be static fires this week, and all the preparation for a launch. So that's going to be happening, and then probably Monday prep or a launch, and Tuesday more than likely a launch, because the root closures are for next week too. They have those in place for a reason. So that's about it. Let me know, of course, what you think about this oil rig situation, them launching rockets to the rig and then launching them from the rig to wherever. That's crazy. And I love it. So thank you to Patreon patrons. You can go to patreon.com/space news pod. Or also click that. There's like a join button down here somewhere. If you're on YouTube, there's a join button. If you're on mobile, I don't know where it is actually, but you can become a member and help out the channel there. So thank you again for everybody who's been supporting the show. And we do live shows every Monday and Friday at noon on YouTube, and also Tuesday and Thursday on Twitch, twitch.tv/space news pod. And check out our merch at spacenewspod.com. These are some of the people that have helped us out along the way. Thank you so much for becoming YouTube members. Without you, we can't do this. So we are growing like crazy. We're over.
Nice. This guy looks pretty cool. I like him. What, NASA? Anything on NASA you can check out? God, there's such long videos. I wish they kind of cut them down a small bit, because like I feel like this could be kind of interesting, but it's a little bit too long. How it looks to land on Mars this week. Let's check this out.
How it looks to land on Mars, previewing space station spacewalks and supplies and cargo delivered for the station crew. A few of the stories to tell you about this week at NASA. Newly released high-definition videos captured by cameras on board our Mars 2020 Perseverance rover show the
nice, and these are images that weren't shown live as well. These are brand new images, I imagine.
Final 7 miles of the spacecraft's entry, descent, and landing on Mars. The uniquely amazing views, including the look down at the separation of the protective heat shield, and the upward views during deployment of the most massive parachute ever sent to another world,
are the closest you can get to landing on Mars without putting on a pressure suit.
Let's have a look what's going on here. You have your rover, and below the rover is Ingenuity helicopter, I imagine. 2 cameras, microphone on the bottom. What's up here? Descent stage. Oh, this is what like landed, like airdropped it onto the surface, I'm pretty sure. And you have your back shell here. There should be a heat shield on the bottom as well, I imagine. I think
on the rover
maybe they're just not talking about
any usable data during the landing after Perseverance touched down. It did pick up mechanical sounds made by the rover operating on the surface, and even a few audible seconds of a Martian breeze.
Ooh.
Also released with
let's look at that again.
On the surface, and even a few audible seconds of a Martian breeze. Also released with the videos and audio was the first panorama of the rover's landing location taken by the 2 navigation cameras on its mast. These were all followed up 3 days later with the release of the rover's first complete high-definition look at its surroundings, a 360-degree panorama from its mast cam Z instrument. Perseverance will use its suite of instruments to search for signs of past microbial life,
it's a drill,
collect
right?
and leave samples of rock and soil for...
That image is, I think, that's iconic. I think it's going to go down in history. It's so, like, that was the image that was first shown when it landed. It just looks so cool. I love it.
Future mission to bring back to Earth and test technologies to help pave the way for future human exploration of Mars. Find out more at nasa.gov/perseverance. We previewed 2 International Space Station spacewalks during a February 24th briefing at our Johnson Space Center. During the first spacewalk on February 28th, our Kate Rubins and Victor Glover will prep for solar array upgrades later this year. Rubins will then go back outside on March 5th with Japan's Soichi Noguchi to vent ammonia from the station's thermal control system along with other tasks.
I didn't know that happened yet.
The Northrop Grumman SS Katherine Johnson Cygnus cargo spacecraft arrived at the space station February 22nd, 2 days after launching from our Wallops flight facility. It delivered about 8,000 pounds of scientific research, crew supplies, and hardware to the
ISU? Yeah.
The spacecraft is named after late NASA mathematician Katherine Johnson, one of the women featured in the book and movie Hidden Figures, who made significant technical contributions to some of NASA's earliest and most historic space flights.
Pretty sure she's involved with the Apollo missions.
On February 26th, our NASA headquarters building in Washington, D.C. was officially named in honor of Mary W. Jackson, the agency's first African-American female engineer, who was also featured in Hidden Figures. Acting NASA Administrator Steve Jerzik led the ceremony, joined by Jackson's family and other special guests, with the on-site attendance limited due to the ongoing coronavirus pandemic.
3, 2, 1.
That looks pretty nice.
The ceremony featured the unveiling of a building sign with Jackson's name and several video tributes, including poet Nikki Giovanni reading from her poem, Quilting the Black-Eyed Pea, which is about space and civil rights. Learn more about the contributions of Jackson, Katherine Johnson, and other NASA hidden and modern figures at nasa.gov/modernfigures. Our Parker Solar Probe captured some surprising views of Venus during a close flyby in July 2020. The image shows Aphrodite Terra, the large
Parker Solar? I haven't heard of this probe. What's going on here? I didn't realize there was a probe hitting Venus at the moment.
largest highland region on the Venusian surface. The team is surprised because based on the imaging device's
Venusian's a great word.
they only expected to see clouds, not clear down to the planet's surface. They are now trying to determine if the imager has unforeseen capabilities, which would provide new opportunities
On the way to
to
the sun,
study
makes
dust
sense.
around the sun and in the inner solar system. The mission focuses on the sun, but it makes several passes of Venus using the planet's gravity to help it fly closer and closer to the sun. That's what's up this week at NASA.
Nice.
For more on these and other stories, follow us on the web at nasa.gov/twan.
All right. Let's get back to work, guys. Let's get back to work. Okay, let's get some tunes going. Okay, so we are in the seepage area, okay? Now, I imagine the difference between macro seepage and micro seepage is a macro seepage would be like a large, like one single large kind of deposit where you have your methane coming out. I think micro seepage might be like multiple smaller holes, let's say. So it's not that micro seepage is inherently smaller than macro, because you might have enough micro seepages around that bypasses the strength of one macro seepage. That's my understanding so far, but I might be a little bit off there. Alright, dope. Of gas with no visible surface manifestation. So maybe macro is specifically when there's like clear, like it's coming from a clear fault in the land. Micro is like when it comes up through like permeable surfaces maybe. But that doesn't make too much sense to me because earlier on in the macro section it did speak about permeable surface. So yeah, I'm just kind of spitballing at the moment. Let's just keep reading. The barrier, Jesus. Okay, NF prime location for methane seepage. The large faults of NF located at the dichotomy. That's a fancy word I've heard a lot but don't know what it means. Let's look it up. A division or contrast between two things that are represented as being opposed or entirely different. Dichotomy. Okay. Oh, I need to put my screen back. Do I have the notes up? Dope. The Aethidus impact is, if you look at a map of Mars, fuck it, we'll do it now. I'll never turn down a chance to look at the globe of Mars. Not exactly, no, it's a map of Mars. This one. So this is the Aethidus. This is the Aethidus planitia, which I assume is like the Aethidus plane, and it's a big impact crater. And Nili Fossae is just up here, like kind of northwest, I guess, but not quite in the impact crater. And the idea is that when this was created, there was like a ripple out effect that kind of hit over in Nili Fossae as well, and that is what created kind of the large cracks there. So that's what the Aethidus impact is. Okay. I don't need YouTube anymore, let's just get out of the way. As suggested by their concentric shape and position at the western edge of the Aethidus basin. Okay. The result, possible that NF may trap, I assume that word should be, may trap deep fluids that float up the impact related rim faults as well as extensional faults associated with the dichotomy, and this combined flow from two separate sets of deep faults may provide enhanced potential for long-term flow of water. Okay. Consistent, yeah, serpentinization. probably the end of the playlist. Hold on. Um, wrong way to say it. Fire playlist. Okay. So that's all about Nili Fossae, really. The rest is other places. I'm just gonna quickly scan through them, but I won't bother taking notes. Again, this is volcano-esque methane, probably. Can seepage fluxes support observed atmospheric CH4 concentrations? So, what's been measured so far? Can our known properties of these seepage fluxes, what they should be, does that alone quantify and reach the levels that we're measuring in kind of the remote sensing, I guess? It doesn't match up, is what this is trying to answer here. Huh. That's pretty weird. More recent models suggest that the spatial and temporal changes of CH4 observed so far can only be explained by a greater thing, with a resulting shorter lifetime of 200 days or even a few hours near the surface. If this is correct, it would imply that a larger source than previously estimated is required to replenish methane in the Martian atmosphere. That's insane. From 200 to 600 years to only 200 days. Okay. What's going on here? So, I think so if methane had a lifetime of 200 to 600 years, then I think on the knowledge that we have of how the methane could be produced in the first place, we would expect a far larger amount of methane to be in the atmosphere. What this is saying is that because we're seeing less methane than you would expect, there must be a bigger sink, which is controlling that methane and changing it to something else. So it says here, such as oxidation by hydrogen peroxide in the regolith. This would mean that methane's lifetime would go from this length to only 200 days. I think that's what's going on here. Okay. I need to get done with this paper. I'm fucking sick of it. Look. Oh, cool. It explains the difference. Yeah, it's kind of like we were saying earlier on. The macro seepage comes from like a big, like kind of crater. As you can see here, it's like a little volcano, and the micro seepage is from like multiple different holes. So the reason why the micro seepage might end up being as big as the macro seepage at some point is because there's just loads of micro seepages together working at the same time. So yeah, that'd be the difference between micro seepage and macro seepage. Go to the bathroom and then we'll go through this paper.